Morning. I'm Jack Davis, the Crops Business Management Field Specialist out of Mitchell office. Welcome to our crop hour for today. We have with us today Dr. Sarah Sellars and Dr. Tong Wang. They're going to talk on fertilizer, price outlook, and some strategies. And we're going to start off with Sarah. We do have, for questions, you can enter questions in the Q&A or the chat, and we'll take those after the presentations. And so you can go ahead, if you think of a question during it, just go ahead and type it in, and we'll cover that at the end. There are also going to be a poll after each speaker, and we'll put up the CCA credits so you can scan that with your phone. But that'll be at the end of each speaker. So I guess, Sarah, if you're ready to share and do a little more introduction on yourself, we can go.
Sounds great. Thank you so much for the introduction. I'll just share my screen here. Okay. So as Jack mentioned, my name is Sarah Sellars. I'm assistant professor and extension specialist in the Ness School of Management Economics. I'm pretty new to South Dakota State University. I just started my job in August and moved to South Dakota from Illinois. So I grew up in Illinois on a grain and livestock farm. So that's where my interest in agricultural economics really began. And I also studied at the University of Illinois for two of my degrees and Purdue Universities for the other degree. So I'm really excited to be here in South Dakota and really excited to be at a university with a winning football team. That was really, really fun this year. So really excited. So today I'm going to be talking about spring fertilizer economic outlook. I'm going to kind of motivate this and set this up by talking about farm income and prices. Then I'm going to talk about what we've been seeing for fertilizer prices. I'm going to talk about ammonia supply and demand, both domestically and globally. And then I'm going to talk about some changes in the fertilizer industry, which could have long-term supply, demand, and price effects. So that's kind of the outline for today. So I'm going to be covering all the good and bad. So there's some positives, some negatives, but overall, I hope it's a pretty positive presentation. So first, I just want to motivate this by talking a little bit about farm income projections for 2024. So on February 27th, the USDA just released their projections for net farm income, production expenses, and gross farm income. So they're projecting net farm income and gross farm income to decline in 2024, mostly driven by the decline in commodity prices. And they're also predicting an overall slight increase in production expenses. So for 2024, they're projecting a 27.1% decrease in net farm income. And for 2024 production expenses, they're projecting a 1.6% increase. So when we're talking production expenses, I'll show you what categories they're talking about. You'll see that fertilizer is actually projected to decrease, so that's a positive. But when we look at other expenses like interest expenses and interest rates going up, overall, that's going to be a slight increase in production expenses. And as I mentioned, a lot of this is softening of fertilizer prices and decrease in projected net farm income is because of decreasing commodity prices. So we've seen corn and soybean prices both decreased significantly from the levels we've seen in the last couple of years. And as of this morning, corn was at $4.30 and soybeans are at $11.75. So this is kind of I said there's going to be positive and negative. So this is one of the negatives, is the decrease in commodity prices. I know there's been a lot of discussion from farmers about that recently. And then these are the production expenses. So this includes both grain and livestock farms. So that's why you see feed purchases. But the reason I wanted to show you this chart is fertilizer is a really a key piece of the farm expenses. When you look at the major expenses for a farmer, you'll see labor, fertilizer, seed, and interest. So fertilizer is a big portion of the farm production expense. So that's why we're really interested in the price and really interested in thinking about the outlook for the upcoming year. And like I said, the fertilizer is forecasted to decrease in 2023 and 2024 based on the USDA projections compared to 2022. But you'll see the increase in other expenses like interest rates, seed, and labor. So that's kind of driving that overall 1.6% projected increase. Now I want to get into actual fertilizer prices so we can look at the trends and look what's been going on the last few years. These are the yearly nitrogen prices from 2012 to 2023. I got this data off of Bloomberg, so we're really fortunate here in the Nest School. We have access to Bloomberg terminals, which have some great nitrogen fertilizer price information and data and reports. So I spent a lot of time on there kind of catching up with the news and with what people are talking about in the fertilizer industry. So in 2021 and 2022, we saw record high nitrogen fertilizer prices. This was a really concerning time for a lot of farmers, but we've seen those prices coming down as commodity prices have decreased. We've seen fertilizer prices decrease as well. So as of the end of 2023, these are the average yearly prices. So I don't have 2024 in here yet, but significant decreases from the last couple of years. And now I just kind of want to zoom in on that graph and look at what's been happening in 2024. So I use this is the weekly nitrogen price. I'm using the New Orleans terminal price. So this doesn't include any transportation cost. So typically, I know that gets transported via barge or rail from different locations across the US. I use the terminal price because it's just the pure fertilizer price. It doesn't factor in those kind of transportation costs across the US. And the trends should be the same, whether transportation price is included or not. I just wanted to look at the pure terminal price. So kind of in the beginning of 2024 and towards the middle and the end of 2023, we saw nitrogen fertilizer prices hit a low around July 2023. Then they came back up a little bit going into late 2023, and then going into spring, we've seen those prices softening again and coming down. Again, a lot of that's driven by commodity prices, but also there's some discussion about planting outlook. So when soybean acres increase, then corn acres typically decrease, and this reduces the demand for nitrogen fertilizer. So some of the Bloomberg reports have been discussing, there's been some talk of decreased soybean acres potentially in 2024, but again, it's pretty early. But if we see projections for soybean acres come out and show increased soybean acres, reduced corn acres, we could see these prices come down even more. And I just wanted to kind of put nitrogen prices and corn prices on the same graph so you can kind of see how the trends follow each other. So this is the average marketing year corn price from NASS. So that's why it only goes through 2022. And then I just put that on with the average yearly fertilizer price for anhydrous ammonia, UAN, and urea. So you can see we have both supply and demand side factors affecting the nitrogen price. One of the main demand side factors is the corn price. So particularly after 2008, if you take this graph back even more, it gets really interesting. So as we kind of reached a new era of corn prices with the ethanol era and the ethanol boom, we also see the nitrogen prices kind of reaching a new era of prices. So as corn prices increase, this does change demand for fertilizer. And that demand is captured in the fertilizer price. We see an increase in price. And again, you don't see the decrease because this graph only goes through 2022. And this graph is a little bit confusing because we've got 3 axes going on here, but the corn price is in dollars per bushel is on the right-hand axis here. So that's the yellow line. And then the nitrogen fertilizer price is in dollars per ton, and it's on the left-hand axis here. So that's the blue, gray, and orange lines here. So you can see how, I guess my main point here is you can see how strongly corn price and fertilizer prices are related. And as I mentioned, shifting in crop acres could also change the price of nitrogen fertilizer. This is data from the Census of Ag, so it's every 5 years. So it's a little bit choppy, but it shows kind of some trends we've seen in South Dakota over the last 5 years, a shift towards soybeans at times, more planted soybean acres when soybeans are more profitable. So when soybeans are more profitable, farmers shift to planting more soybeans. So in some years when we see a strong difference between the soybean and corn price, we see soybeans surpass corn in planted acreage. So again, if we see that projected for the US, if we see high projected soybean acres for 2024, we could see shifts in nitrogen fertilizer prices decreasing even more. I also just wanted to briefly mention the DAP price. I didn't take this too far back. I just kind of zooming in on the recent price trends we've seen in DAP. Again, this is at the New Orleans terminal price, so no transportation costs included. But as of early 2024, that was selling, and this is the spot price at the terminal. So this is not the retail price that I'm showing. So that was selling a little under $600 per ton. Then we also have our potash price. Here I'm using the Northern Plains price. And again, I got all of these prices off the Bloomberg terminal. So it's called Green Markets. They keep track of all this fertilizer data. They have some really great data sets. So here for potash, I'm using the Northern Plains price. So this does include transportation cost. And again, I'm just kind of looking at recent trends since 2023, but we've also seen that potash price coming down and right at about $400 per ton as of early 2024. Now I want to talk a little bit more generally about fertilizer supply and demand. I'm going to specifically focus on nitrogen fertilizer. One, because it's such a significant input cost for production. And two, I have the most experience kind of working with nitrogen fertilizer research. So it's something I'm really, really interested in. So I'm going to talk a little bit about the nitrogen fertilizer market, both domestically and globally. So I want to talk a little bit about what's been happening with U.S. ammonia production and consumption since 2019. So we've seen some expansion of production. So I'll show you a slide in a little bit, but the majority of our ammonia is produced domestically. So ammonia is the base product, and then this can be transformed into UAN or urea or some other fertilizer products as well. And ammonia is used in some manufacturing, but most of the ammonia produced in the US is used for agriculture. So there's been a stable period of low natural gas prices. So this has allowed for some expansion of the ammonia production in the US. And we've also seen some investment by the government in decarbonization of the ammonia market, which I'm going to talk about in a little bit. But we've seen this long period of low and stable natural gas prices. Natural gas is the main kind of feedstock into ammonia production. So this has made it economical for companies to upgrade their existing facilities and also expand their facilities. So we've seen some expansion in production. I forgot to put the numbers in here, but we've seen some decrease in capacity as well. So a typical statistic they that gets looked at by the government is, okay, how much of our ammonia fertilizer capacity are we using? So we've seen that decrease over this time period to, I believe, is around 9% last year. So, and consumption of ammonia fertilizer is projected to increase by 1% per year globally. So expanding production, expanding capacity, expanding supply, but also increased consumption is projected. And when you see the imports, which are the orange line, it looks like we're not really importing a lot of nitrogen fertilizer, which is true relative to our domestic production. But when you look at this 2,000 metric tons on a global scale, you'll see that U.S. is importing more than some countries are. So on this chart, it doesn't look very significant, but as an importer, this 2,000 metric tons is a significant number. And we really don't export much. That's the gray line here, just a small amount of exports. The imports come typically from global companies that have production facilities in Canada or Trinidad and Tobago, kind of off the coast. So mostly come from North American production facilities from large global fertilizer companies. And then I just wanted to talk about global ammonia production overall, because this is a topic that will affect fertilizer outlook and price going forward. So these are the latest numbers released from the U.S. Geological Survey. They put these together every year. So it's some really interesting data. So over the next 5 years, they're projecting the U.S. is going to keep increasing their capacity around 2% per year. And this includes our decarbonized ammonia projects, which I'll talk about in a little bit. And globally, ammonia capacity is projected to increase 6% over the next 4 years. So we see some other countries expanding their production as well. A lot of these are in places where there's low-cost natural gas, such as Central and Eastern Asia, Eastern Europe, and North America. So that's where we're going to see the most production expansion. Some other countries are proposing decarbonized ammonia plants as well, but most of that focus has been here in North America. And as I mentioned, consumption of ammonia fertilizer globally is projected to increase by about 1% per year. So you'll see that China is the largest producer of ammonia at 43,000 metric tons in 2023. And then we have kind of United States, India, and Russia all tied at around 14,000. Now I want to talk a little bit about changes in the fertilizer industry that could affect fertilizer demand and supply, thereby affecting fertilizer price. So these are definitely some topics to watch as we go forward. So I just want to kind of briefly explain the chain of nitrogen fertilizers. This was part of an extension project I worked on with a soil scientist. So I did kind of the supply and demand analysis, and then he made this nice little chart, which I really like to show, but it shows how basically nitrogen is made. So nitrogen from the atmosphere is captured by using hydrogen gases as a feedstock. Typically, typically nitrogen is produced by producing a reaction using natural gas. So that's why a lot of the production facilities in the U.S. are in Texas and Louisiana, where there's large stocks of natural gas to supply that reaction and produce the ammonia. So then the resulting product is anhydrous ammonia. And then this can be further refined over here into different products. So using different chemical processes, you can produce urea or UAN, MAP and DAP, ammonium nitrate. So that's a little bit about how that process is all interconnected. And that's why urea and UAN are typically more expensive than anhydrous ammonia, because they're produced from anhydrous ammonia. But there's been a push to decarbonize the ammonia industry. So this reaction using natural gas is very energy intensive. So it's a large proportion of total emissions. Usually when we're looking at how the US government counts these emissions. They usually get counted in industry's footprint and not agriculture's footprint. So agriculture typically looks a little bit lower, their total carbon emissions, than if we counted the production of nitrogen fertilizer to agriculture. But it's a really energy intensive process. So they've been looking for ways to kind of make that more efficient. Since this process was kind of invented in the early 1900s, I don't think there's been any major change in how nitrogen fertilizer is really produced. There may be changes in the process, but the scientific process has not significantly changed. So one thing they've been looking to do is integrate carbon capture into this hydrogen production. And there's different ways they can do that, but basically I wanted to point out that there's been a large investment in this program to produce these regional hydrogen hubs. It's a total of $8 billion in investment. So this large investment in the infrastructure of hydrogen should, in theory, affect nitrogen fertilizer prices by securing and increasing our domestic capacity, and also by, in theory, should be able to increase production and produce more with less energy. But again, that's a new program and it's just kind of rolling out now. I also just want to briefly mention biological nitrogen fertilizers, because these have potential to affect the nitrogen fertilizer market. It's kind of a new product, a revolution. A lot of people are talking about it. I think there's a lot of research that's needed. There's a study that North Dakota State University Extension published in combination with 10 other states. That's kind of just a one-year snapshot. So I think more research is needed, and we know that weather really affects things. So more research over time would be useful, but I think a lot of farmers are thinking about these products, maybe experimenting with these products. So if these products were to capture a significant share of the market, in theory, this would mean a reduction in nitrogen, synthetic nitrogen fertilizer use, which would further decrease demand, which would, in theory, decrease the price. But again, this is kind of a looking forward to the future topic to watch. And then I just wanted to briefly mention risk management strategies. And I know Tong's going to get more into different strategies related to inputs and production. But when thinking about fertilizer risk, you typically have fertilizer price risk, but also weather risk related to fertilizer application, especially if you're doing split fertilizer application. So I just wanted to point out this crop insurance endorsement product. You can add it on to your existing YPRP or RP with harvest price exclusion policy. And it's available on select counties in South Dakota so far. This is from 2022 when they, this map is from 2022 when they kind of rolled out the pilot project. So I don't know if that's expanded at all yet, but basically it allows you to ensure your split application nitrogen decision. So if you apply part of your nitrogen, but you're not able to get the other part applied due to weather conditions, you can receive a crop insurance payment to cover that weather risk. So that's just bringing that up as kind of another thing to think about with managing fertilizer risk. And just to kind of wrap up, net farm income is down, mostly driven by lower commodity prices, which also has caused fertilizer prices to decrease considerably from previous years. So I think after the couple of years of high input prices, this is kind of some relief thinking about lower input prices because there was a lot of pressure financially on margins. But also when you think about the lower commodity prices and the cost of fertilizer in bushels of corn, actually farmers are probably not that much better off. But this could change again if fertilizer prices soften even more, or if we see some change in commodity prices. Corn acres for the upcoming year, natural gas prices, and commodity prices will all affect nitrogen prices. And then I just kind of wanted to point out that our strong domestic ammonia production and this investment in decarbonizing hydrogen production and kind of this interest in biologicals all have potential to affect the fertilizer market long term. And then I'll just close with that. I want to share my contact information here. I'm happy to take questions, and you can also feel free to email or call. I love talking with people and providing information. So happy to share any of this information or data with you or answer any questions.
Have any questions, you can sure type them in, or and we can take them that way. If you don't have any questions, if you think of them, sure, type them in. I believe Sarah's going to probably be around yet through this. And Tong, if you want to get started and do a little more introduction, we can start with that.
Thank you. So good morning, everyone. So I'm glad to present my topic today. Is the practices that reduce reliance on synthetic fertilizer. So my name is Tong Wang. I'm an advanced production specialist in South Dakota State University. So the topics I'm going to cover today, first, I'm going to introduce different practices that reduce synthetic fertilizer usage. So the topics here we cover includes cover crops, diversified crop rotation, variable rate fertilizer application, manure, microbial fertilizer. And I'm going to introduce our 2021 and 2022 survey among the Midwest states, so which shows that adoption rates of different practices across different states and regions. And then I conclude with factors to consider when determining the best adaptation strategies to reduce fertilizer use. Okay, so with the fertilizer reduction practices or technologies, so here we have cover crops. So as we know that cover crops, they are planted to protect soil surface during the fallow periods or following the harvest of the one crop and before planting of the other crop. Diversified crop rotation is the rotation of 3 or more crops in set or variable sequences on the same field. And the variable rate fertilizer application, which is a precision technology and offers a site-specific management tool that accounts for in-field variation in nutrient availability to enhance fertilizer use efficiency and minimize losses. Manure, it can be used as a substitute for a chemical fertilizer, which increase crop yield, and it is a soil amendment that improves soil health. So finally, microbial fertilizer, which is also referred to as biofertilizers and bioinoculants. So it uses naturally occurring processes involving beneficial soil and plant microorganisms to improve soil fertility and enhance crop production. So with this 5 different technologies and practices, I also summarize their potential benefits and potential barriers for each of the practice. So for cover crops, we know that cover crops improves soil fertility and structure, which controls the pest and suppress weeds, and provides additional nitrogen to cash crop, decreasing nitrogen leaching, and which also improves soil carbon sequestration. The potential barriers for some producers, however, could be high cost, establishment difficulties. It might be hard to eradicate. And for the people located in northern regions with low temperature, there's usually a narrow planting window. And sometimes farmers could have the difficulties because of the lack of labor and time. So diversified crop rotation, similarly, it also improves soil fertility, reduces fertilizer requirement, breaks pest and disease cycle, increases crop yields, and promotes ecological diversity. The barriers could be it requires specialized planting equipment. Sometimes it also has some crop insurance constraints. Producers also feel like there's no profitable 3rd and 4th crop. And sometimes there is a lack of marketing information for some producers. And in some regions, there could be an inadequate local infrastructure. So those are the potential benefits and barriers for those two practices. And for variable rate of fertilizer application, it enhances fertilizer use efficiency, minimizes nutrient losses, and reduces nutrient runoff and leaching. The high cost and steep learning curve could be the potential barriers. And manure, we know manure improves soil structure, enhances soil organic matter, and substitutes synthetic fertilizer, which is also resilient to international supply and price shocks. However, manure has varying nutrient quality. It has a low nutrient value to mass ratio. It also has a high transportation cost. If used in excessive amounts, it could pose environmental and health risks. And microbial fertilizer improves soil fertility and enhance crop production, substitutes the synthetic fertilizers, and reduce environmental pollution. However, it also has some barriers currently. For example, there's a lack of storage facilities, variabilities in usage efficiency, and it is not adaptable to all type of soil and climate. So those are the potential benefits and barriers of the practice we listed. And so here I'm going to introduce some of the survey results that we found from our 2021-2022, the Midwest Farmer Survey. It covers 4 states, which includes North Dakota, South Dakota, Minnesota, and Nebraska. So first, we started with 6,000 farmers in 2021, which resulted in a 20% response rate. And in 2022, we resurveyed those people who actually responded to our 2021 survey. So we have a more than 60% response rate with 1,652 responses. So our survey is conducted in 2021 summer, which you can see that in the summer of 2021, we have a rising fertilizer price. And the 2022 summer, we have the fertilizer price at its peak, is slightly going down, but still at the peak price. So that's why when I ask the producers, the top 3 factors that are likely to influence farm operations, weekend fertilizer is the most likely to influence, rated by 41 producers, 41%, and then 27% producers rated as second most likely to influence. And for the third most likely influence, most producers choose repairs. So repair cost is also a concern for producers during those years. So the questions we ask about those practices is whether they have used one of those practices. If they have used multiple, they can choose multiple. And if they haven't used it, if this continues, and what is the likelihood for them to use the practices in the future. So we can see that here is the data showing that among all the practices, the most likely used is first is manure, which is 37.8%. Then is a variable rate fertilizer application, which is 37.2%. Even though they are very similarly used in 2022, however, if you look at the future growth trend in the next 3 years, we can see there is a high potential for the variable rate fertilizer application to grow, so which can be grown to 66%. However, the growth potential for manure is relatively low. And the highest growth potential actually is in microbes, which is microbial fertilizer. Even though the current usage rate is only 14.5%, but the expected growth rate is highest, which is over 100% for these microbes. And then we can see the crop rotation and cover crops. The usage rate is one of the lowest, and the growth rate is not very high as well. So by state, we can see that by state, the practices used by different states actually varies. I use a green bar here to stand for South Dakota. And we can see that if you look at crop rotation, South Dakota is much lower than North Dakota, which is reasonable because crop rotation is generally used in the low temperature and low precipitation regions. And then cover crops, we can see South Dakota has the highest usage rate of cover crops. It has one of the highest usage rate in the variable rate fertilizer use and manure use. Which is very similar in manure use to Minnesota. And for microbes, South Dakota is one of the lowest, but it's not significantly lower than other regions. So here I just plotted it by in the map, so we can see that by county how different practices adopted by different regions. So here is diversified crop rotation. We can see North Dakota has the darkest color here, which means the highest adoption rate. And the cover crops, South Dakota among all the regions has the darkest color, which has the highest adoption rates in the cover crops. And the manure, we can see Minnesota has the highest manure adoption rate. And South Dakota also is one of the highest adoption states. And we look at those across states, how the usage trend could change over the years. So this is from a 2021 survey result. So we can see that in 2015, compared to 2015, 2020, the chemical usage rate has significantly increased. So which we ask for the nitrogen fertilizer usage for corn production, and the unit is pounds of nitrogen per acre. So this is significantly increased from 2020 to between 2015 to 2020 for all the states. And then if we ask the producers their targeted rate in 2025, however, we can see a significant decline. The target rate is even lower than 2015. So which shows that the producers in different states, they all target some lower fertilizer use. And if we look at different practices, how it's going to affect the fertilizer use. So here is some data we pulled together from the adopters and non-adopters of different practices. So we can see that people who adopt the diversified crop rotation and compare with people who did not use DCR or diversified crop rotation. So people who did not use it have a significantly higher chemical fertilizer usage. And the rate of manure fertilizer use is similar across the two groups. And if we look at the livestock integration into cropping practices, then we can see that people who have livestock, then they have much lower chemical fertilizer use on their field. The reason is we can see down here because they use much more manure fertilizer. So the manure fertilizer use kind of substitutes the chemical fertilizer use. And another practice we plotted is cover crop. So cover crop, we can see that the adopters have lower, significant lower chemical fertilizer usage as well. And we didn't see much difference between the manure fertilizer use across the two groups. So from those differences, we can see that cover crops and integrating livestock into cropping production and the diversified crop rotation, all those practices, the adopters have actually used them to significantly lower their chemical fertilizer use. So for conclusion, we can see that adoption rates for cover crops, diversified crop rotation, and manure actually demonstrated significant regional differences. Therefore, it is important to consider the regional infrastructure and the climate factors to determine the best adaptation strategies. And we can see that the expected growth rate is the lowest for manure compost, which is less than 20%. This is due to the spatial separations of crop and livestock production. So sometimes if there's no livestock production nearby, or if the producer did not integrate livestock with their crop production, it can be very difficult for producers to locate manure sources. And the highest expected rate in adoption rates comes from microbial fertilizer and the variable rate fertilizer. So one is more than 100% growth rate, the other is more than nearly 80% growth rate. So which demonstrate that this new technology-oriented adaptation strategies are most favored strategies to reduce the reliance on the synthetic fertilizer. So that's all for my presentation, and you can see my contact information here. And let me know if you have any questions. Thank you.
Again, we can type questions in for either Dr. Tong or Sarah or Dr. Sellars, and if we have any questions, and we'll share a poll also. Again, if you guys got any questions, you can sure ask them at this time. And I think we've shared the contact information. So if you want to get a hold of either Dr. Sellars or Dr. Tong, you can sure do that. I think coming up tomorrow, we have Laura Edwards is going to present our spring climate outlook and summer outlook, and then also the outlook for flood. And I'm not quite sure who's presenting on that one. But, those will be up tomorrow.
Yep, tomorrow will be Julie Meyer from NOAA's the River Forecast Center out of Kansas City. They forecast for the Missouri River Basin, so she'll join me tomorrow.
So I think that's what we have for today. If you guys don't have any questions, we will close out the day. Thank you for joining us. Thank you for being a part of it today.